Hold a single grain of sand at arm's length against the night sky. It covers a patch of darkness so small it seems like nothing at all. Yet point the Hubble telescope at that exact scrap of emptiness and leave the shutter open for days. In that pinprick of blackness, 10,000 galaxies quietly burn. Every one of them a city of 100 billion suns. We think we already know how big things are. A mountain feels enormous, an ocean endless, the horizon almost too far to walk. But these are the measurements of an animal that evolved to judge the leap between two branches. The universe was never built to human scale. Tonight we are going to leave that scale behind, and we are not going to stop until it breaks. We begin with something you can hold, and we will not rest until we reach the edge of everything we can ever see. Along the way the numbers will stretch, then strain, then snap. There will come a moment when your mind simply refuses to follow any further. Remember that moment when it arrives. It is the most honest thing the universe will ever tell you about yourself. Look closer at that grain of sand. Inside it are roughly 100 quintillion atoms, a 1 followed by 20 zeros. If you counted them at 1 per second, you would need far more time than the universe has existed many times over. And here is a question to carry into the dark. Which is the greater number, the atoms in this single grain, or the stars in the entire observable universe? Hold that thought. We will come back for it. Now shrink into one of those atoms. It is almost entirely empty. If the nucleus were a marble resting on the floor of a cathedral, the nearest electron would drift somewhere near the distant walls. Everything between is void. The solid world you lean on, the chair, the ground, the mountain, is more than 99.9999% nothing at all. Matter, it turns out, is mostly the memory of where matter isn't. Pull back. The grain sits among countless others on a beach, and the beach runs for miles, and coastlines wrap the entire planet. There are more grains of sand on Earth than most people can even frame as a number. And yet, as we are about to see, this whole ocean of grains is a rounding error. It is barely the first step of a staircase that has no top. This is Earth, 12,000 kilometers across, the largest thing most of us will ever truly feel. A jet airliner takes about 2 days to circle it. Light, the fastest thing that exists, laps it more than 7 times in a single second. Keep that speed in your mind, the speed of light, because from here onward it becomes the only ruler long enough to measure anything. Every other measure is simply too short. Now the sun. You could pour more than 1 million Earths inside it. It hangs 150 million kilometers away, so far that its light takes 8 minutes and 20 seconds to reach your eyes. Which means something strange is always true. If the sun went dark this instant, you would stand in full sunlight, unaware, for 8 more minutes. And here is the open question. How far does that delay stretch once we leave the sun behind? The answer begins to frighten. Sunlight that took 8 minutes to find us needs 4 more hours to crawl out to Neptune, and hours beyond that to escape the solar system entirely. We have left the planets behind, and light, which crossed the whole Earth 7 times a second, has now been traveling for hours. We are no longer measuring in kilometers. From here we measure in years, and the very first neighbor is impossibly far away. The nearest star beyond our sun is Proxima Centauri. Its light, moving 300,000 kilometers every second, still takes 4 years and 3 months to reach us. Look at it tonight and you see it as it was 4 years ago. Now plant this question and hold it tight. If the closest star is 4 years away at the speed of light, how long would light need just to cross our own galaxy, edge to edge? This is the Milky Way, our home, a slow whirlpool of 200 to 400 billion stars. The Sun is one of them, circling the center once every 230 million years. The last time we sat in this exact spot, the dinosaurs had not yet appeared. And the answer to our question is staggering. Light does not cross this galaxy in years. It crosses it in 100,000 years. One galaxy, 100,000 years of light. 100,000 years ago, our ancestors were chipping the first stone tools. A beam of light that set out then, from the far rim of the Milky Way, would only be arriving now. And this is still just one galaxy, a single lit room in a house we have not begun to map. Step outside that room, out beyond the last of its stars, and the floor drops away completely. This is Andromeda, the nearest large galaxy to our own. Its light left 2.5 million years ago, when the first members of the human family were learning to walk upright in Africa. It is the most distant object the unaided human eye can see, a faint smudge that is, in truth, 1 trillion suns. And it raises the question that will define everything left. If Andromeda is only our neighbor, how crowded is the rest of the street? Andromeda and the Milky Way are just two of more than 50 galaxies bound together in what we modestly call the local group. Zoom out, and the local group is a single node inside the Virgo supercluster. Zoom out again, and Virgo is merely a suburb of Laniakea, a structure of 100,000 galaxies, all of them sliding toward one mysterious point we cannot even see. And Laniakea, too, turns out to be small. At the largest scale, galaxies are not scattered at random. They hang in vast luminous threads and sheets wrapped around enormous empty voids, a structure astronomers call the cosmic web. It looks unsettlingly like the neurons of a living brain, billions of galaxies strung along filaments millions of light-years long. And somewhere on one faint thread is a single dot you could never pick out, everything you have ever known or loved. So how far can we actually see? The observable universe stretches about 93 billion light-years across. Inside it are an estimated 2 trillion galaxies, holding somewhere near a septillion stars, a 2 followed by 24 zeros. These are not really numbers anymore. They are the noises we make where numbers used to be. The mind reaches out toward them and closes on nothing at all. But there is a wall. Look far enough in any direction and you strike the edge of sight. Not the edge of the universe, but the edge of what light has had time to carry to us since the beginning. Beyond it, the cosmos almost certainly continues, perhaps without end. We simply cannot see it, and we never will. That light has not arrived yet, and space itself is stretching too fast for it to ever catch up. That is the quiet horror folded inside the beauty. The universe is expanding, and the most distant galaxies are already receding faster than their light can travel toward us. One by one, across billions of years, they will slip past the edge of sight and vanish forever. The universe we can see is not merely unimaginably large. It is the largest it will ever be. We happen to live in the era when the most can still be seen. Now, the question we planted at the very beginning, which is greater, the atoms in a single grain of sand, or the stars in the entire observable universe? The grain holds around 100 quintillion atoms. The observable universe holds close to a septillion stars. The stars win by a factor of many thousands. The entire visible cosmos, every sun in every galaxy, outnumbers the atoms in the grain of sand between your fingers. Sit with what that actually means. Each of those septillion stars is itself built from unthinkable numbers of atoms, and around many of them turn worlds, and on some of those worlds, perhaps, beaches and grains and something bending down to look. The staircase runs in both directions without end, down into the atom and out past the edge of light, and you are standing, impossibly, somewhere near the middle of it. This is the moment we promised you at the start, where the numbers stop being information and turn into something closer to weather. You cannot hold them. No one ever could. But you were assembled from the same collapsing star stuff as everything out there, and for one brief flicker of time, that dust learned to look up and count. The universe is almost entirely empty and almost unimaginably vast. And somehow, Tonight, it is looking back at itself through your eyes.